Hey everyone, it's Mr. Oda. In today's video lesson, we're going to be going over topic 4.7, solar radiation and Earth's seasons. So before we get into that, we want to talk about real quick our enduring understanding. So from this lesson and a couple other lessons, the big thing you guys need to understand is that most of Earth's atmospheric processes are driven by input of energy from the sun. The sun is our main source of energy, and it changed a lot of things about how the planet works. So for today, we're going to explain how the sun's energy affects the surface of the Earth. In this lesson, we're going to be talking about how we get the different seasons and how the tilt of the Earth affects that. Now, a term that you're probably going to hear a lot of is insolation. And the only thing that insolation means is the incoming solar radiation. So it's the amount of energy that the Earth is getting from the sun. And the amount of energy is actually the solar radiation from the sun divided by the area that it hits. So if the sunlight is spread over a larger area, the energy or the heat is actually going to be less. And this is the reason why generally we understand that the equator, the center of the Earth or the middle of the Earth, gets more direct sunlight and therefore is warmer than something like the North and the South Pole, because there's a larger area, the light is spread out more, and so it's colder in these areas. And again, this is a cartoon illustration to show that the area near the equator has a much smaller area. The sun's rays are focused here, so there's going to be more heat, whereas the poles are larger areas where the sun rays spread out, and so it's going to be much colder there. There's going to be less energy in that area. Now, one thing you could do to kind of see this is actually by using a flashlight. If you have ever used a flashlight against the wall, you'll see that it has a certain area, but if you tilt the flashlight or tilt the surface, the light is going to appear to be larger, but it's going to be less bright. It'll become dimmer as the angle increases. Now, the Earth, as you know, is tilted a little bit. It is not straight up and down. It is at a 23.5-degree angle. And so because of this, some areas of the Earth get more direct sunlight than others, depending on the time of year. So in this example, we have a couple of different areas that we need to kind of memorize and keep in mind for the remainder of the lesson. We have the equator, which is at 0 degrees. It is generally considered the middle of the Earth. And then as you go up north, you have the Tropic of Cancer, which is at about 30 degrees north over here. And the Arctic Circle, which is at around above 60 degrees north up here. In the southern hemisphere, you have the Tropic of Capricorn down here, and the Antarctic Circle down here. So in this case, you'll notice a couple things. One, the northern hemisphere, where we are, North America and everything else, we are facing towards the sun more than the southern hemisphere. And so in this case, we are getting more direct sunlight because of the tilt. And so due to this, you have the different seasons. In the case here, the northern hemisphere is facing the sun. That means that this would be summertime for us, whereas down here, it would be winter for the southern hemisphere. The seasons are caused by the tilt in the Earth's axis. So in this case, the sun is over here. We have summer for the southern hemisphere because they are more directly facing the sun. They are closer. Whereas we in the northern hemisphere are kind of pointing away. And so you have winter. It's a little bit colder over in the northern hemisphere here. So just to briefly go over the seasons in the northern hemisphere. So again, where we are, these are a couple of different dates that you want to memorize. The most important ones being the solstices, the winter and the summer solstice. The winter solstice is on December 21st, 22nd, somewhere around there, and you have it being the shortest day of the year. So for us, we get the least amount of sunlight, generally less than 12 hours. And one thing to know also for the Arctic is that they actually get 24 hours of darkness during this time because they are completely facing away from the sun. Due to the tilt, they will not get any sunlight for 24 hours. As you move ahead to the spring, you get the vernal equinox. This is where day and night are roughly equal, so about 12 hours of sun, 12 hours of night here. And that's for both hemispheres. When you get to June and the summer solstice, you have the longest day of the year. So now you see we are facing the sun. We're going to get more sunlight, more heat energy. And you're also going to get something called the midnight sun. So for the Arctic right here, you'll notice because of the tilt, they're going to be getting 24 hours of sunlight as opposed to 24 hours of darkness over here. Finally, when you get to the autumnal equinox, you're again going to have day and night roughly equal, about 12 hours each. And keep in mind that these are different or opposite for the southern hemisphere. Whenever it's summer for us, it is winter for them. And when it's summer for them, it is winter for us. The equinox days are the same. Apologies for the typo. For them, the longest day of the year is in December, and their shortest day is actually in June. Now, to practice this, we're going to look at a couple multiple choice questions. The first one being, the primary cause of Earth seasons is the what? Hopefully you were able to remember that it is due to the tilt of the Earth's axis. Now, for this question, you're going to have to remember the names of certain lines on the Earth. The diagram to the left shows the Earth tilted at 23.5 degrees on its axis. As shown in the diagram, which region is currently experiencing the highest insolation? Which area is getting the most sunlight? Right. Hopefully you will remember, we're looking not at the equator necessarily because it isn't getting the most direct, but we're looking over here. And so for that, we're looking at the southern hemisphere. And if we go back, we're looking at this area, which would be the Tropic of Capricorn. Now, on that note, as shown in the diagram to the left, what is the approximate length of day at the Tropic of Capricorn? The Tropic of Capricorn would be down over here. How much daylight would they be getting? Hopefully, since you know that this is most likely summertime for them, they're going to get more than 12 hours of sunlight. And finally, based on the graph, which of the following can be concluded about the latitudes of the two locations? Take a look at how much solar radiation location 1 and location 2 get throughout the year. And tell me, what can you assume about these locations? This one might have been a little bit tricky. Hopefully you were able to get that. Hopefully you were able to learn a lot from this lesson. If you have any questions, please ask them in class, and I will see you in the next video lesson. Take care.